Question 9, okay. For all n elements, for all n element n, so n has to be a natural number which starts from 1, so 1 all the way upwards, okay. U of n equals 5n minus 3 by 2 to the power of n. Verify that u to the n plus 1 minus 2 to u to the n is 5 to 2n plus 1. Okay, so what we're going to do first and foremost is we're going to write down what u of n is. 5n minus 3 bracket 2n. Then we're going to get u of n plus 1. Replace all n's with n plus 1. Minus 3 times 2 to the power of n plus 1. That's going to be, remember to save yourself a bit of time, it's going to be 5n plus 5, which will make that 5n plus 2. 2 to the n plus 2 is going to be 2 times 2 to the n. Then multiply the 5n plus 2 by 2, and you're going to get 10n plus 4, 2 to the n. Okay, now that's done, what we're going to do next is we're going to put it into the formula, okay, what we just found out. So what we're looking for is u to the n plus 1, which will be in green. So u to the n plus 1 is going to be 10n plus 4, 2 to the n. And then it wants me to take away, which in red, 2 u to the n. So minus 2 u to the n, which is 5n minus 3 by 2 to the n. And I have to prove that this equals 5 times 2 to the n plus 1. Okay, so what I'm going to do is going to multiply them out on the left. Yes, Stephen? Now, going to multiply this out, we're going to get 10n 2 to the n plus 4 2 to the n. Now this one's delicate, okay, it's going to be minus 10n, and then that in turn gets multiplied by 2 to the n, so it's going to be 10n 2 to the n, and then it's going to be plus 6 2 to the n. That's when you multiply it to get 10n minus 10n plus 6, okay? So it's going to be minus 10n 2 to the n, and then plus 6 2 to the n, and I have to prove that it's 5 2 to the n plus 1. Okay, these guys cancel as expected, and what we're going to get is 10 2 to the n. Now we might have hit a bit of a crossroads here. They are actually the same, but it's actually recognizing that they're the same as the skill. So what I can do here is, see the way that's a 5 and that's a 10. Break up 10 into 5 multiplied by 2. Okay, and then you can change that into n plus 1. 5 times 2n plus 1 equals 5 times 2n plus 1. Hence we proved it. You could have also worked on the right hand side at the start and just changed that to 10 by 2 to the power of n. Once you prove they're exactly the same thing, there's no bother. Who got it out? Okay, next one is for all positive integers, f of n equals 2n minus 1 plus 2n minus 1. Now to pick up marks, okay, so I did this one yesterday? No, I didn't. No. To pick up marks, I'll just read the first part of the question. Show that f of n plus 1 minus 2 f of n minus 2 to the power of 2n equals 0. So to pick up marks, you're just going to say, alright, n plus 1. Replace all n's with n plus 1. So it's going to be 2 times n plus 1 minus 1 plus 2 times n plus 1 minus 1. Now, trick here is that's going to be 2n plus 2 minus 1, which is going to be 2 to the power of 2n plus 1. Right, the next one is going to be the 1's will cancel. Okay, and when the 1's cancel, what we're going to be left with is 2 to the power of n. That's f of n plus 1. That's that part done. Okay, now I'm going to go straight into this question here. Right, write down f of n plus 1. F of n plus 1 is 2 times 2n plus 1 plus 2 to the n. It's asking you to take away 2 multiplied by the original formula. the original formula being 2 to the 2n minus 1. 2 to the 2n minus 1 plus 2 to the n minus 1. What's the n part of that then? Minus 2 to the 2n. Is it minus or plus? Sorry. Minus 2 to the 2n. And that all that's equals 0. Now, this is the part that's going to get you. Okay? Everything is grand here apart from one part. There's one part that's causing the problem. Can anybody tell me which part is causing the problem? This part here is causing the problems. Okay? Now, what you got to remember is it's actually two simpler questions. Okay? Forget about the minus at the start. What's 2? What's 2 multiplied by 2n minus 1? Can anybody tell me that? What happens when I multiply that? Have to add the powers, don't I? So what's n minus 1 plus 1? N. So the answer to that is 2 to the power of n. So the first one is going to be minus 2 to the power of n. When I multiply those two by each other, I'm going to get minus 2 to the n. The next one is I'm going to have to multiply 2 to the power of 1. Oh, sorry. Excuse me. Sorry. 2n. So it's going to be 2 to the power of 2n. Excuse me. Okay. The next one is 2 to the power of 1 multiplied by 2 to the power of n minus 1. Once again, add the powers. This is going to turn into minus 2 to the n. Now, you're looking at both sides. And you're going, okay. Let's see what we can cancel off here. Okay. What we can cancel off here would be 2 to the 2n. Oh wait, we can't do that. Excuse me. The only one we can cancel off is these two, isn't it? Yeah. Yes, you go.
Where did half that bracket go?
This? Yeah. I showed you. I multiplied 2 to the power of 1, which is the first black line. 2 to the power of 1 multiplied by 2 to the power of 2n minus 1. You add the powers and you get 2 to the power of 2n, because 1 plus 2n minus 1 is 2n. Then you add the powers of these two. 1 plus n minus 1 is n. So the next one is multiplying it out. And that turns directly into this part here. Now, what we're left with is this. Can anybody tell me what is 2 to the n plus 1? What does it mean if we expand it? 2 times 2 to the n. Change it to 2 times 2 to the n minus sorry, once again, forgetting my 2. Sorry guys, this is what I'm looking to figure out. What is that? It's 2 to the power of 1 by 2 to the power of
4 to the
okay, no, it's not 4. I'll show you now. Okay, it's this, guys. Okay, it's 2 to the power of 1, 2 to the power of 2n. Do you see, when you multiply them together, you add the powers and it turns back into your 2n plus 1. Happy with that?
2 by 2.
So it's going to be 2 times 2 to the n minus 2 by 2 to the n minus 2 to n minus 2n. You have 2 of them, then you take away 2 of them. So what happens? 0 equals 0. Another way of thinking it would be, think of a random letter like y equals 2 to the 2n. Then this question becomes 2y minus y minus y, and that's 0. So it's actually is 0. So 0 equals 0. So if you're struggling with visualizing the powers cancelling, you could always replace them with a letter. That will help you visualize them. Okay. Okay. Next one. Replace all n's with n plus 2's. Okay. Now, some of you, what I'm often asked is, how do I know to change them? Okay. Now, this is what I get for f of n plus 2. Everybody in the class will get that. That is no bother. Okay. Now, what I'm looking at is my original one. My original one has 3n, 3 to the power of n, and 4 to the power of n. I want to convert n plus 2 into the same language. As I don't want 3 to the n plus 2. I want 3 to the n's. So I'm going to use that first rule we were talking about a second ago to reverse the process. It's going to be 3 squared 3 to the n. Now I'm back to 3 to the n, which is what I want because it's the same as the initial question. Same with the one after that. It's going to be 4 squared, 4 to the n. Now I go to these two and I go, okay, that's 9 and that's 16. 16 and 9. I'm going to multiply the letter by that number, and what I'm going to get is 9p 3 to the n, and then I'm going to get 16q 4 to the n. I'm going to stop there. Now it looks a lot more similar to the initial question, okay, or the initial function, okay. So does anybody have any questions thus far? Continue here. What we're going to get next is f of n plus 1. Same deal. Just replace it in 3n plus 1 plus q 4n plus 1. Break it up using a rule. It's going to be p times 3 by 3 to the n plus q times 4 by 4 to the n. And then what's going to happen here is we're going to get 3p 3 to the n. And then we're going to get 4q 4 to the n. Okay, how many people got that far? Well, with the start? How many people got f of n plus 1 and f of n plus 2 correct? Okay, a couple of people, alright? Make it smaller. Okay, next thing. I'm going to read off my question. F of n plus 2. 9p 3 to the n. 16q 4 to the n minus 7 times f of n plus 1. So I'm going to do minus 7 times. I can multiply it straight away, can't I, if I wanted to save time, but I won't. 3p 3 to the n plus 4q 4 to the n. That's in the blue region. And then finally we have the red region, which is plus 12 times our original function, which is p 3 to the n plus q 4 to the n. Now that's the 3 different segments of your big question: black, blue and red. Matter of just doing them all out. So once again, 9p 3 to the n plus 16q 4 to the n. Now multiply this out: minus 21p 3 to the n minus 28q 4 to the n, and then plus 12p 3 to the n plus 12q 4 to the n. You really got to spell it out. Now the best way to spell it out is factorizing. Put 3 to the n on the outsides, and inside is going to be 9p, because it's 9p 3 to the n, minus 21p, because that's the next one in line, and then the one after that in line is plus 12p. And we can see that 9 plus 12 minus 21 turns into 0. No p's remaining. Then we have 4 to the n, and what we're multiplying 4 to the n is first by 16q, second by minus 28q, and third by 12q. Closing brackets. All of this should equal 0. So what you can say here is that all of this turns into 0. All of this turns into 0. So it's 3 to the n times 0 plus 4 to the n times 0. 0 equals 0. Proven.